Friends, this is Dr. Anand Pai coming back with the next series in Physics 101, in that part 1 mechanics and in that kinematics, and this is class 3 which will be on acceleration in one dimension. Let us continue. First of all, what is the definition of acceleration? Acceleration is the time rate of change of velocity. And acceleration is a vector quantity. A is given as dv by dt, where v is the velocity. Just like last time, we said about differentiation. Differentiation means slope, right? So here also, in this is the slope of the velocity versus time graph. So if I have a graph of velocity versus time, that is v as a function of time, then this particular thing works. For example, if our velocity is a function of time, then we will have a curve, and the slope of that curve is actually acceleration. Now there are two things, instantaneous and average acceleration. Just like we have instantaneous velocity and average velocity, we have instantaneous acceleration and average acceleration. What is meant by instantaneous acceleration? At any point, the slope at a point gives an instantaneous acceleration. And what is average? It is the change in velocity by change in time along any 2 points taken. That will give the average acceleration. So what we have to do? We have to note down what is the delta v, and we have to see what is the delta t. So average acceleration is actually delta v by delta t. Clear? So here, slope of the velocity time graph at any point gives the acceleration, that is instantaneous acceleration. Next, let us talk about acceleration versus time graph. Now acceleration versus time acceleration, we know dv by dt. Now let us understand, can we take some gist out of this, just like velocity versus time graph. See here, now change in velocity is a into dt, just that I have taken this on this side. Okay. Now we are integrating both sides from point 1 and 2. Now we know integration implies that we are finding the area under a, which is a function of time graph. Okay. And when we see this particular thing being area, we get the area under this. So what is this here? That would be the change in velocity, because integration of dv is delta v from 1 to 2. So this is delta v from 1 to 2 gives the area under the graph from 1 to 2 points. That's point 1 to point 2. So change in acceleration, or the area under the acceleration time graph gives the change in velocity, but not speed. Keep in mind, there's a difference between speed and velocity. Here it is velocity and not speed. Okay, it is velocity but not speed. Okay, so that is very important to understand. This is velocity is correct, speed is wrong. So what happens? This is a change in velocity, not change in speed. Very important. Number of competitive exams this is asked. Okay, next, so area under the acceleration time graph gives the change in velocity. Now let us understand this. Again, one more repetition. Velocity is ds by dt. So ds is v into dt. Here delta s, which is the change in displacement, is area under the velocity time graph. This is displacement. Displacement is right. Displacement is right. Distance is wrong. So if somebody says distance is area under the velocity time graph, then it is a wrong answer. Similarly, if you consider area under the acceleration time graph, the area under the acceleration time graph is actually change in velocity, not change in speed. Okay, so let us go further. Let us now understand more about acceleration in one dimension. Now when we have a zero acceleration, okay, zero acceleration means acceleration will be zero, right? And what is acceleration? It is dv by dt, which is 0. Now we can do one thing. We can say dv is equal to 0 into dt. Now let us integrate both sides. Now we know that differentiation of a constant with respect to time is equal to 0. That means reverse should be true, is it not? So velocity should be constant, right? Students, this is not true in every case. Okay, in this case it can be assumed so, which is engineering freedom we have, but mathematically speaking this is not 100% accurate, but let us go with it. Okay, so here acceleration, when you integrate, which is acceleration which is 0, you get a velocity is constant. So velocity, when you differentiate, you will get 0 acceleration. So zero acceleration means, intuitively also, it means that velocity is constant, right? Now if the velocity is constant, how is displacement changing? Displacement has to change linearly. How is that? Because velocity is change in displacement per time, which is a constant. So ds is equal to constant into dt. When you integrate this, you get s is equal to constant into time plus another constant, say c1. So this is about zero acceleration. When there is zero acceleration, velocity is constant and the displacement is changing linearly because velocity is the same, right? Now let us talk about constant acceleration. When we talk about constant acceleration, here what is happening? A is equal to constant. So what will happen here? You can write dv is equal to c into dt. Let us integrate this. When you integrate this, you get velocity is equal to c into time plus a constant, another constant, say c2, right? So now what is happening here? The velocity will have an equation of a line, right? Because this is the line equation, which is y is equal to mx plus c. M is the slope, so c is the slope. Acceleration is the slope. So slope at any point gives the acceleration here, which is constant. So slope from this point or this point, anywhere you take a point here, it is same, is it not? That is what is reflected here. Any time the acceleration is the same, so velocity is linearly varying. Now let us talk about the displacement. Now here displacement, when you say, we have to integrate the velocity, right? So integration of dv is equal to, or integration of v dv, I'm very sorry here. So it should be integration of v into dv, which is equal to, or v into dt, I'm very sorry here again, v into dt is equal to integration of c into t plus c2 into dt, right? So now here, when we integrate this, we get c into t square by 2, this is s here, plus c2 into t plus another constant c3. Now if you observe here, this is a parabolic curve, is it not? It's a parabolic curve, it's a second order curve, is it not? So second order curve which is there, here you see a second order. So what's happening? If you want to find the velocity, what is the velocity? That's the slope over here. The slope over here is here. That is the velocity. So this velocity is corresponding slope here. This slope s, say s1, if I say this is a slope s1, would be the equal to velocity v at this particular point, at the same corresponding point. Okay. So this is how we have to understand, right? And the slope is constant everywhere. For the velocity, slope is constant everywhere for the velocity, that's why acceleration is constant. Slope is increasing linearly in the displacement, so here velocity is increasing linearly. Hope you get the point. Similarly, we will have linearly increasing in acceleration. Linearly increasing acceleration, then what happens? This becomes second order equation, this is second order. You can do the math and you can see, and this becomes a third order, that is you get in terms of t cube. Here we have got t square and here we will get that as t cube. So what is happening? Third order, this changes as t square, this changes as t, this changes as t cube. So one order increase when you go lower. That is, acceleration is one order less than velocity, and velocity is one order less than displacement. This intuitive understanding is very important in solving problems. Let us continue. Let us do some problems which has come in exam. Very simple ones. Okay, especially in these competitive exam students, we have to first attempt easy questions, and easy questions we have to do it properly. Okay, so here let us see some of the easy questions. Tougher questions I will do in subsequent videos, but let us go with the easy questions now. So a particle is moving in a straight line. The variation of position as a function of time is given as t cube minus 6t square plus 20t plus 15 meter. The velocity of the body when the acceleration becomes 0 is. Let us see that. So first of all, x is given, right? X is given as t cube minus 6t square plus 20t plus 50, right? Now let us differentiate this, because velocity is differentiation of displacement dx by dt, which is equal to 3t square minus 12t plus 20, right? T square, this 2 comes here, t raised to 1. And here again, we'll differentiate this again. You will get d square x by dt square will come as 3 into 2, 6t minus 12, right? What is asked? The velocity of the body when the acceleration becomes 0. Means what is this? This is the acceleration, right? And this has to be 0. Means what? We have 6t minus 12 should be equal to 0, and this comes as 6t should be equal to 12. This implies time should be equal to 2 seconds, right? Now if time is equal to 2 seconds, then we have to substitute. Okay, what is asked? Velocity is asked. So we have to substitute t is equal to 2 seconds in the velocity equation. What is velocity equation? Dx by dt, that is the velocity, right? So velocity is equal to 3 into t square. Instead of t square, we will put 2 seconds. So we will have 2 seconds here. So 2 square minus 12 into 2. Wherever t is there, we are substituting 2 plus 20. So this would be equal to 3 into 4 minus 24 plus 20. And at the end, you will get this as minus 4 here plus 20, minus 24 plus 20 minus 4, and 12 minus 4 is equal to 8. So answer is 8 meters per second. Next. This is a fantastic question which has come in JEE Mains 2023. Given below are two statements. Area under velocity time graph gives the distance traveled by the body at a given time. Area under the acceleration time graph is equal to change in velocity in the given time. Now the options are both statements are true, both statements are false, both statements are true. Statement 1 is incorrect, statement 2 is true, statement 1 is correct, statement 2 is false. Let us understand. If you see here, statement 1, what it says? Area under the velocity time graph gives the distance. This is a mistake. It is not distance, it is displacement, as we have discussed this previously, is it not? So it is displacement. And area under the acceleration time graph is equal to change in velocity. That is proper. If they had put change in speed, then it would have been wrong. So here we have to be careful whether it is velocity or speed, here whether it is distance or displacement. So statement 1 is incorrect, but statement 2 is true. I hope you understand, students. Next question. Now, the thing is, the relation between time t and distance x for a moving body is given by t is equal to mx square plus nx, where m and n are constants. The retardation of the motion is, where v stands for velocity. What is that? Let us look at it. We will have this as t is equal to mx square plus nx. Now observe here, this is a bit tricky question in the sense that They have not given x as a function of time, but they have given time as a function of x. So here, in this particular topic, a student being good in differentiation is very important, right? So we have to practice differentiation as much as possible, differentiation as well as integration, okay? Especially this comes in 11th standard, but differentiation comes in the 12th standard, but it's always better that we learn differentiation and integration before learning this, okay? So let us differentiate this. We will get this as dt is equal to m into 2x dx plus n dx, right? This way of differential element type of differentiation will save a lot of mistakes. So now let us take dx outside and bring it to the denominator of the left hand side. This will become 2mx plus n. What is this? This is dt by dx. If I want to use dx by dt, which is the velocity, this is given as 1 by 2 mx plus n. Right. So now let us continue further. What is this? This is velocity. Let us differentiate this again. Now differentiation of velocity, that is dv by dt, will come as, here when you consider dv by dt, in this case we have this as 1 by x. So differentiation of 1 by x is actually equal to this is equal to differentiation of minus 1 d by dx of x raised to minus 1, which is equal to minus 1 into x raised to minus 2 plus minus 2, right? So differentiation of this is x raised to minus 2. The same thing we can do here. So we can have this as, and then a chain rule. Okay, let us do that. So this one will become 1 by 2mx plus n raised to, here instead of plus 2, we are at the below here in the denominator. It can come as square 1 by, so it is 1 by this, and then you have a minus 1 here, so that's why I put minus. But then when you have a chain rule, this is a function of x, is it not? So we have to differentiate this again. So when we differentiate this again, you will get 2m, right? So when you differentiate this again, I'm sorry, here when you differentiate this again, you will get it as 2m, and then you have this x here. We are differentiating with respect to time, so we will have this as dx by dt. Very important to understand chain rule properly, that we should not miss out on this, right? So this would be equal to, we'll have minus here, we will take 2m here, but then you see here 1 by 2 mx plus n is actually velocity. So this would become equal to, I'll put in this fashion, students, let it be like this. So this would be 1 by, this would become v square, is it not? Sorry, not like this. So it will become v square here, right? This whole thing, 1 by this will be square, so it will be v square into 2m plus dx by dt is also velocity. So this comes as minus 2mv cube is the answer. So the answer would be A, which is 2mv cube. I hope you have understood this, students. Now further going, I will be solving, I'll be having videos on kinematic equations, and all the 3 kinematic equations when we solve, later on we will solve questions from JEE Mains as well as NEET exam as well as AP physics exams. So we will solve all the problems here, and we will get in-depth understanding of mechanics of motion in 1 dimensions. So hope you have enjoyed this lecture. If you have any suggestions or feedback, kindly put it on the comments, or if you want me to solve some specific problems in this particular topic, please put it on the comments. I'll be more than happy to solve. So happy learning, students. Have a nice day. Thank you.